going to tell you about the latest work that Dimensional Insight is doing to integrate data science technology into what we do. And we'll use that term broadly to include machine learning and artificial intelligence. So there's no disputing that these technologies are amazingly powerful. All you need to do is to send an instant message from your mobile phone to understand how things like speech recognition and natural language processing can streamline things that you routinely do. But the challenge lies in applying these technologies to practical business problems in ways that add significant value beyond what could be done without them. In other words, how can they help without getting in the way? There have been some hard and expensive lessons learned over the last few years, and it's worth touching on them. One example is IBM Watson. Watson demonstrated that it could beat world champions in Jeopardy and chess. And IBM subsequently made big bets that Watson could make a difference in areas like healthcare, manufacturing, and finance. But it's struggled to apply it in ways that added value. Diagnosing cancer, for example, turned out to be a much harder problem than Jeopardy. The data was messy, determining what to predict was challenging, and it was unclear how to integrate useful information into how work gets done. What IBM did learn, the hard way granted, is that there's a variety of opportunities to apply data science to somewhat less glamorous operational business processes to increase efficiency and productivity. Now, at Dimensional Insight, we agree that this represents a practical, value-oriented approach to leveraging data science. And here are 4 reasons why we feel there's a particularly good fit between Dimensional Insight technologies and data science. First of all, extensive data management capability. 75 to 85% of the work in data science involves sourcing, integrating, transforming, cleaning, and validating data. And those are things that we focused on from the beginning. And that produces the highly reliable quality data needed for data science algorithms to work. Then there's the integration with open source data science algorithms. And it turns out that the Diver platform architecture is pretty good for that. And then finally, Dimensional Insight's industry-specific applications provide highly curated measures and KPIs that these algorithms need to really work well. Okay, so there's plenty of potential, but that brings us back to the fundamental question of which problems and use cases to focus on. And we've identified a variety of different use cases that actually work across industries. And a few of them include forecasting sales, projecting inventory depletions, identifying problem accounts, ideally in advance, such as accounts receivable. So here's what we're doing to make that a reality. So we're starting with a keep it simple approach with a potential for quick wins. One set of techniques that fits with these goals particularly well is time series. And that's the area that we've chosen to focus on first. So why time series? A couple different reasons. One is that it can be applied broadly across an extensive set of use cases and industries. Secondly, it's a very well understood problem with proven solutions. There are open source algorithms readily available in platforms such as Python and R. And it's straightforward to implement. It actually doesn't require a lot of different data. And then importantly, it produces understandable and actionable information that can be put to work on the front lines. Okay, so I'm going to give you an example of what we've been doing in this area. This involves a prototype that we've worked with one of our customers in healthcare to build. Although, as I think you'll see, this approach is broadly applicable across industries and use cases. So this prototype allows you to select a measure or a KPI. In this case, it's produced by Measure Factory through one of Dimensional Insight's healthcare-specific applications. So over on the left-hand side here, you can see that there's an extensive selection of measurements. And then we click Run Forecast, and it takes about 30 seconds to run or generate a new forecast. And what it produces is a chart that shows a series of predictions day by day in the variable that we've selected. And this variable helps predict bottlenecks in this particular workflow. And we can see the correspondence between the historical experience and the predictions. And then we also see out on the right-hand side a future forecast. Now, we've done this with two different algorithms. This is a simple regression algorithm. We also used a more sophisticated time series based algorithm. And you can see that the fit between the predictions and the actual historical experience is much closer, a much tighter fit. That means that as we look at this projection, several days or weeks into the future, we've got a pretty good idea as to how confident we can be in those projections. So this can be very helpful information for predicting staffing levels, identifying bottlenecks in advance. And it could be applied very similarly to things like sales forecasting, for example. Both these approaches integrate adjustments for seasonality, which is important in forecasting because there are variations by day, by week, and by season. And the technologies that were used here were Measure Factory to produce the data, open source algorithms from R, which were integrated via DI production, and DIUC for the presentation. And if you're interested in the underlying statistics, there's plenty of information here to understand what's going on under the covers. So with that, if you're interested in how this particular approach could be applied to problems and use cases in your area, feel free to give us a call, brainstorm with us, get in touch with your account executive, or if you'd like to talk in more detail about the specifics of this approach, feel free to email me at gdealy@domins.com. Thanks for listening.